Hi, I'm Max Scheida with Lincoln Traps, and today I'd like to go over some common troubleshooting procedures for the Lincoln sporting machines as well as Lincoln skeet machines. The first step of troubleshooting any trap machine, whether it's a Lincoln or otherwise, is to ensure that the power supply is suitable for the machine. The easiest way to do this is if you have multiple machines. You could swap out batteries from one machine that you know is working to another that isn't, or a transformer if they're hardwired. One thing I would like to go over though is the use of solar panels, batteries, and how voltage relates to all of that. So I've got a battery here, and if I use my multimeter and check the voltage, I get about 1.5 volts. So very low, not nearly enough to run the machine. In pretty much every case, if the voltage to the machine is less than about 12 volts, it's essentially running pretty low. But sometimes when batteries are used in conjunction with a solar panel, the battery voltage can be a little bit deceiving. So I've laid this solar panel here with a long-range solar controller hooked up to it. And right now, this solar controller is reading 13.6 volts. So if I go ahead and hook this solar controller up to our battery, and now I read our battery voltage again, I'm reading 11.7 volts. So as you can see, just simply hooking up the solar panel to this battery greatly increased the voltage reading that I'm getting off of it. But even though that now reads nearly 12 volts, there still is very little capacity in this battery, because if we remove the solar panel clips, we know it's going to drop back down to that roughly 1.7 volts. The issue here is if you're only checking your battery voltage with a solar panel hooked up, it may not be a true picture of the state of the battery. So what I'm going to do here is clip my leads into here so that it's hooked up in conjunction with the solar panel. And here I'm still getting about 11.7 volts. And now I'm going to hook my machine up. So this is our Lincoln 10-column 500 target capacity machine. And I'm just going to hook this up to the other posts on this battery. Again, still now getting about 11.5 volts. My power light has turned on my control box. Now, if I actually go to turn this machine on, my voltage drops to 3 volts. And the relay in the control box just erratically clicks. So as soon as I put any load to this battery, the voltage just completely drops down and there's not sufficient voltage to actually power the machine. So this is really important because simply reading the voltage is not always a true measure of the state of the battery, especially when a solar panel is hooked up. Be sure to disconnect any accessories such as solar panels or extra wireless release systems. You want to simply isolate the machine and the power source to eliminate any other variables from that system. So we've learned how to verify if our power source is effectively providing power to the machine. But another issue that we commonly see is how damaged cables can cause problems. So here I have a known good power supply. If I take my voltmeter probes here, I'm getting 13.3 volts. And just to show that this machine is functioning with this power supply, I'm going to hook up my positive and ground, and I can go ahead and arm this machine. We can see that I have a power and a cock light, and I can go ahead and release it. This machine is working properly. So I'm going to disconnect this for a moment and show you this box. This control box is one that a customer sent in and is a pretty common scenario that we see. If we look at the power connections for this control box, we'll see that the original copper clips have been removed and have been replaced with these ring terminals. Just replacing the clips with ring terminals in itself is not so bad of a thing to do if that's how you want to use the machine. However, we strongly recommend getting a very high quality solid copper terminal. Many of the terminals on the market are a zinc plated product that outdoors in the environment that most of these machines are used in, we see it quickly corrode, and you just lose part of that connection as soon as that starts to corrode. But the primary problem that we're really looking at here is that many of the strands of wire have actually snapped off at this point where the ring terminal is connected. So the original wire that had many strands that were all together carrying the current required to power the machine now has been reduced to maybe half or less strands. So we've taken the current carrying capacity of this cable and significantly reduced it at this point. And what happens here is this really creates a bottleneck in the system. So now we've limited our capacity for power to move. So I'd like to show an example of how this can actually affect the machine. So I run this machine. We know that this machine functions properly using this power supply. Now, rather than replacing this cable with a damaged one, I'm going to use this small cable in line between my positive side of my power cable for the machine and my battery terminal. And this is going to simulate the bottleneck of that damaged cable. So if I hook up this smaller wire to my positive lead and then hook it up to the battery here, you'll see that if I use my voltmeter and probe around inside the control box, I can contact a ground terminal and contact a hot terminal inside the control box, and I'm still getting nearly 13 volts. So as far as using a multimeter and inspecting inside this control box, it still shows that I have voltage in the places that I should have it. You'll see that the power light is on because the control box is in fact receiving 12 volts. But if I try to cock the machine, the light goes out. So what happened here? Well, this wire is not able to carry the current required to actually turn the motor. So when the motor attempted to turn, that motor was drawing a greater load than these LEDs. So the LEDs go dark as the motor tries to turn because it's drawing the most current. But regardless, this is so restrictive that the motor is not able to turn at all. So we had 12 volts in the box, we had a power light, but the machine was not functional due to this restrictive cable, or in the field, a damaged cable. So a really important thing to do when troubleshooting a machine that's not functioning is to inspect this power cable. And really inspect all of the cables on the machine. Most machines are outdoors in the weather. There's rodents that can chew through wires. A lot of machines get moved around often and these cables can get tugged on. If you tow your machines on carts through brush can catch these wires and pull on them and really impact the connection points. So opening the control box, making sure the wires all look good, making sure the wires outside the control box look to be in good condition. And furthermore, you can pull back these rubber boots and actually inspect where the wire connects to the terminal, and really ensure that all of the power connections look to be in good condition. Now, if all your power connections are in good condition, we can move on to some further troubleshooting. We're going to talk about a couple of issues that can come up. One of the more common issues that we hear about is windmilling. Windmilling is essentially when the arm just continues to rotate around and fire a target, and it never actually stops in the cock position. It just fires nonstop. This can be attributed to a couple of different things, and we're going to talk through them. The first thing, which is the simplest, is a faulty release system. Whether it is a cable with a manual push button or a wireless remote, issues can happen with either one. These buttons can stick, or the relays in the wireless remotes can stick, and that will be just giving the machine the signal to fire forever. This is very easy to diagnose. In most cases, you can simply unplug your release cable from the machine. This is a release cable that I know is bad, and what we can do here is I'm going to hook it up. I'm going to hook the machine up to power. And right now the machine has power, but the rocker switch is in the off position. But since this release cable is bad, as soon as I turn this to the on position, the machine is just going to continually fire. So we can see that that machine just continuously fires. But now if I disconnect this and I turn it back on, it comes into the cock position and stops. Again, if I were to plug this back in, it immediately causes the machine to fire once again. This is a really simple thing to troubleshoot. If you are having a windmilling problem, the first thing you want to do is just disconnect your release system. I'm going to go ahead and hook up a working remote for us to continue looking at some things here. The other two common causes of windmilling are going to be the relay, which is the block found in the center of your circuit board. It's a 5. These are very easy to replace. They simply pull straight out, and you can insert a new one straight in. They can only be installed one way, so there's no ambiguity about how this actually goes in. But what can happen is, over time, there's a little mechanical finger in here that actually moves and makes contact to fire the machine. It can happen that that finger will get stuck in the closed position, and in that case the motor just is getting power all the time and will continue to fire. Again, if you have multiple machines, simply swapping one of these from a known working machine can be a very quick way to diagnose these. These are also pretty inexpensive to have on hand, are a quick and simple way to see if that's the problem. The other culprit of this problem can be the reed switch. This switch is located on the opposite side of the machine. I'll go ahead and rotate it here. This switch is located here on the side of the frame of the machine, and it interacts with a small magnet that is mounted to this link here. So this arm travels around and drives the indexing of the magazine, but it also controls where the throwing arm stops when it comes into the cocked position. So as this magnet travels over the reed switch, it again has a small finger in there that makes a contact. So when that contact is open, the motor should run, and it should try to run until it comes back to the point where the magnet meets, at which point that switch stops the motor. Again, over time, these can fail, and that finger will no longer stop in the correct location. So what can happen is they will fail in the position where the motor is just constantly running. So we do find that these switches can have a degradation over their lifespan. A switch that has begun to degrade does not necessarily need to be replaced right away, but it may require an adjustment to be made. The switch is actually mounted to an L bracket like this one, which is then secured to the frame of the machine. And moving this whole switch and bracket assembly, front or back, will adjust where the arm stops when it's in the cocked position. Moving the whole switch and bracket assembly forward is going to stop the arm later. Moving the whole assembly toward the rear of the machine is going to stop the arm earlier. So if the machine is windmilling and firing through, you'll want to stop the arm earlier to prevent that arm from over traveling past the cock position and firing again. So there's a 3/16 head Allen bolt here. If you just loosen that, you can slide the whole bracket assembly toward the rear of the machine to try to stop the arm a bit earlier. What you don't want to do when adjusting the reed switch is actually move the switch relative to the bracket. The switch should always be all the way toward the bend in this bracket at the end of the slotted mounting point. All the adjustment should be made by moving this entire assembly. The magnet should also never be adjusted. That is set from factory, and adjustments to that can cause issues down the road. This switch is the same for all Lincoln machines. However, the way it's used is slightly different on a Skeet machine. So if we look at the back side of this bracket, it actually has two sets of holes. If we're looking at it this way, the left set of holes are for Skeet machines. The right set of holes are for sporting machines. Same parts, but how they're assembled is different if it's for a Skeet or a sporting machine. Another common issue that we hear from people is that they are not able to get their machine to actually fire at all or run. And it can often be a similar troubleshooting procedure as the windmilling. Just as the relay can fail in a way that it is always closed, causing the windmill, it can also fail in a way that it is always open, meaning that regardless of the input from the reed switch telling the motor to run or not, or regardless of your input from your release, that relay is not capable of actually closing the contacts and sending power to the motor. Again, this is a pretty simple thing to troubleshoot. If you do have an extra relay that you can try, that's going to be the simplest way to really troubleshoot the relay. The reed switch can also fail similarly as well. We talked about if it fails in the closed position, causing the motor to run all the time. It can also fail in the open position, in which case the motor will never run. There is a way that we can actually troubleshoot for that scenario. So on our circuit board, if we take a look at a loose one here, this green terminal block with the 3 screws is where the reed switch wires actually connect to the circuit board. The reed switch wires into this junction box, which comes through this wire and up into the control box and ultimately connect to the circuit board here. On the circuit board, these contacts are numbered 1, 2, and 3, 1 being at the bottom and 3 being at the top. What we can do is actually short across these contacts and cut the reed switch out of the system. So if a faulty reed switch is causing the motor to not run, we can pretty easily test this. The easiest way to do this is with a pair of needle nose pliers, but a scrap piece of wire will also work. If the pliers are insulated though, this will not work. They must just be a basic pair of needle nose pliers. If we contact the number 1 and the number 3 screws, you can actually just put your needle nose pliers ends directly on those screw heads. This will cause the machine to run, or it should cause the motor to run. If you can make this contact and the motor runs, then that's a pretty good bet that the reed switch has failed. Now, when you go to do this test, be aware that the machine could run. So make sure that you're in a safe place, that the target path is clear. You don't want to be doing this in a shop. But you can do this test where you actually contact those outer 2, the number 1 and the number 3, and that should cause the motor to run. So we can do that here on this machine. We're hooked up to power. The rocker switch will need to be in the on position. So essentially we've cocked the machine. Now, if your motor is not running and the machine won't cock, that's fine. We can still do this test, but the rocker switch will need to be on to actually conduct this test. So now, if I take my needle nose pliers, I'm gonna go in here and contact the number 1 and the number 3. And I can cause the motor to run. So I'm gonna go ahead and release this. So that's a quick way that you can actually cut the reed switch out of the system and force the motor to run. It can also tell us something else. Whenever the cocking motor is running, the relay will have to click in order to run the motor. So if we do this test and the relay doesn't click, that may also be an indication that we have a bad relay. If we do this test and the relay does click, but the motor doesn't run, then we may be back to either a motor issue or a gearbox issue or an incoming power issue. The other thing is that you can test on this same 3-pin terminal block is the opposite side of this contact. So when the motor isn't running, the machine should be in the cocked position when the machine's on. What you can do is do the same test across the number 1 and the number 2, and the cocked light should come on. Now this will work regardless of if the rocker switch is on or not. So right now I have the rocker switch in the off position, and I'm going to take my needle nose pliers across 1 and 2, and here the cocked light is on. All I'm doing there is replicating the signal that the reed switch puts out. I am just cutting the reed switch out of the equation by making these contacts. If you try to make your machine run by performing this test and it's still not running, then we may need to do some further investigating, and feel free to call into our office, and we're happy to help you troubleshoot that. But if that runs the machine, that is a pretty good test that we can do to say the motor runs, the relay is switching that power, and everything seems to be in working order except for the reed switch. One of the other issues we hear from time to time is that the machine can be operated here at the control box. If they turn the rocker switch on, the machine will cock, and moving the rocker switch down to the release position will fire it. But they're unable to fire it from the remote, whether that's a wired remote or a wireless remote. And so there's a troubleshooting process we can do to verify that as well. If we look at our circuit board again, and this is actually the cable that goes in and plugs onto the circuit board. So you see this plug here, this is the same thing that goes into the control box. This plugs onto the circuit board in the middle at this 3-pin terminal. So what you'll want to do is open up the lid on your control box, and this connector has a small little locking tab below it. You'll need to depress that locking tab. A flathead screwdriver or a pocket knife works really well to do that. But what we can do here is actually, again, test using these prongs on the circuit board. So again, these are numbered 1, 2, and 3. The number 1 is on the right, the 2 is in the middle, and the 3 is on the left. Number 1 is going to be 12-volt power, or really it'll be 1 volt less than your input voltage. There's some loss in the circuit board, so if you've got a battery outputting 13 volts, you'll probably see 12 volts off of this number 1 pin. The number 2 is the signal to actually fire the machine. We complete the circuit between the number 1 and the number 2. So when you use a push button remote, essentially you are just closing the circuit and sending the output 12 volts back into the number 2 pin. The number 3 pin is a ground, and you should be able to see continuity between this ground and your battery ground. What we can do to test the actual release system of the machine is to short out across these prongs, just like we had before with the reed switch. So if we actually short between the number 1 and the number 2, if you can simply just use a flathead screwdriver and go in there and make contact between these 2 pins on the circuit board, and that'll fire the machine. Again, you want to make sure downrange is clear when you do this test, but contacting those 2 pins should be the same as pressing the push button on a remote. We can go ahead and actually perform this test here. I'm going to go ahead and depress the locking tab and remove this connector that goes out to my plug from the circuit board. So with that disconnected, I'm going to go ahead and arm my machine. And then I'm going to take a flathead screwdriver and contact between the number 1 and the 2, and we should see the machine fire. Just like that. I'm going to go ahead and release this for safety here. This is a great way to verify if the issue is somewhere kind of downstream from the circuit board, or if the problem is in the circuit board itself. If you try to perform this test and contacting those 2 pins does not fire the machine, then most likely the circuit board is the problem. If you do this test and the machine fires, well, then there may be some issue either in this section of cable or in the cable going to your remote or to your wireless receiver. Troubleshooting that can sometimes be a little bit challenging. This can be damage to the actual physical cable. Sometimes these plugs become corroded. On the actual release cable side, it can be the same problem. There can be corrosion inside these plugs. There can be an issue with the cable here. So figuring out where that issue is can be the challenging part there. But if you're able to do this test and fire the machine by contacting these pins on the circuit board, then you know that your circuit board is good, and really it's something in the wiring between the circuit board and the push button or the receiver that is causing the problem. Another issue that can come up here is that if you're using a wireless receiver, the receiver does not power up. And this is kind of the same test. Like I said, the number 1 is your 12-volt power, and the number 3 here is your ground. So if there's an issue with one of those connections to your receiver, it's not going to power up. And you can even kind of test this further. So if you're using a regular wired pull cord, this is only ever going to use the number 1 and the number 2 wires, because this does not require any power to it. So if the machine will function with a cord, a cable release, but it won't function with a wireless receiver, then most likely there's an issue with that number 3 ground. What we can do to verify that we're actually getting the hot and the ground off the circuit board is if we take our multimeter, and to do this test, we're going to have to turn the rocker switch on. So you only get power out of this plug when the machine is in the on position. So now I can go in here with my probes, and if I put my positive on the number 1 and my negative on the number 3, I am getting 12.2 volts. So right there, I know that I'm getting power off of the circuit board. So this is the whole system between my circuit board and my receiver. So at this point, if you know you're getting power off of the circuit board, you'll have to inspect this whole system here. The cable, this connector at this end, both of these plugs, as well as their engagement to each other, and then the cable that actually goes from this plug to the receiver. So you'll want to make sure that all of that is in working order, because if you're getting power off of the circuit board, but not to the receiver itself, you're going to find the issue here. Now, if you're not getting power off of the circuit board, if you put your probes from your voltmeter across 1 and 3 and you don't get any power, it can be one of 2 things. The simpler culprit of this is a rocker switch. The circuit that actually supplies power to those pins goes through the rocker switch. So even if the rocker switch seems like it is functioning properly, it's firing and releasing the machine, if the contacts that actually go on the outside of the box get too corroded, it will not supply power to the wireless. One of the things that you can do here is replace the rocker switch, but before doing so, applying some penetrating oil back behind the actual portion of this that moves And working this back and forth can sometimes clean the contacts and restore it. It's best to disconnect the battery while you do this so that you're not firing the machine over and over again. But if you disconnect the battery, spray some penetrating oil in here and rock this back and forth, that may make a difference. So you can try that. If that does not work, you can try a new rocker switch. And ideally that solves the problem. If you've replaced the rocker switch with a new one and there is still no power from those pins on the circuit board, then unfortunately it's going to be a bad circuit board that must be replaced. So a few components that aren't really associated with a specific issue but we haven't discussed yet are the circuit breaker and this 5-conductor cable. So the circuit breaker comes through the side of the box here. And if there's some overload to the circuit, typically this is going to blow. And if the machine is hooked up to a power source and you're not getting any power light on the side, it's a pretty good indication that the circuit breaker may have popped. So go ahead and check that before doing anything else. Now, if the circuit breaker did pop, that's often an indication that something else has caused the circuit breaker to pop. So you'll want to maybe do some further investigating to see if, was there simply a jam that you were able to clear or something else going on there. In environments that are really prone to rust, you will find corrosion inside these boxes sometimes. When you see a circuit breaker that has a lot of corrosion on it, it's probably a good time to replace that circuit breaker, because when there is some overload, if this is corroded internally, it may not actually break the circuit. And in that case, it'll just continue to be a closed circuit, and it may cause further damage. So if you are troubleshooting something and notice that there's a lot of corrosion showing on the rivets that actually hold this circuit breaker together, it may be a good idea to replace this. The other component that we haven't touched on much here is your 5-conductor cable. So your 5-conductor cable goes from the control box and to the junction box. Inside here, we have 3 wires that are dedicated to the reed switch, and then your 2 power wires for your motor. If you're doing any troubleshooting that you're having issues with the motor not running, you'll want to inspect this cable. Here at the spade connectors, where it actually connects to the circuit board inside the box, if there is some kind of overload that the circuit breaker did not catch, we'll often see damage to these wires. So if you do see heat damage to these wires, this cable is something you want to replace, because if they are heat damaged, that's just going to continue to add more resistance to the whole system. Making sure this wire or this cable is in good condition is important to the function of the machine. So this has covered some basic issues that come up frequently on these machines, but it is not a fully comprehensive guide. So if after reviewing this video you're still having trouble working on your machine, please feel free to give our office a call. Typically we have someone on site that can offer some tech support during our business hours. It's best to be at the machine when you do call, because we can walk you through things. And our website also has some good resources on it as well, as far as troubleshooting and replacing parts and maintaining your machine. So thank you for watching, and thank you for being a customer of Lincoln Trap. We hope this video has helped.